million years ago, Earth got slammed by an asteroid a dozen miles across that took out the dinosaurs and nearly 70% of all other land species on Earth. Probably won't happen tomorrow or even in 100 years, but it will happen again. The fossil record demonstrates to us that what has happened in the past will happen again. How do we protect ourselves? As a minimum, we need an active, fertile space program. What better reason is there to think about defense, not of our borders, but of our species? But also, I see the space program as something that will carry our dreams into the future.
The future is under construction today, 250 miles above the Earth. 16 nations have dedicated their highest science and human effort to build an international space station. Our stepping stone for the exploration of new worlds. It is the most ambitious engineering feat ever attempted. This technology and spirit of adventure promises to touch all our lives in the 21st century and beyond. December 3rd, 1998, the Space Shuttle Endeavour delivered a 12-ton payload into orbit, the American Unity module. The crew's mission to begin construction of the International Space Station.
I hope it was quite a sight for everybody outside. It sure was spectacular inside.
Waiting to be joined with Unity was the unmanned Russian module Zarya, launched into orbit a month earlier. These structures had never been connected together on Earth. Now the engineering of two very different cultures would have to mesh perfectly the first time. There would be no second chance.
All the computer technology, all the differences in electrical, pneumatic systems, it all had to fit the first time. And it had to not only fit, but it had to function when we turned on the light switches in the computers.
Endeavor to get a good view of camera Alpha.
We are watching.
No, this is nice. Keep her coming, and the out the window view is awesome.
There's about 14, 15. Drive me this off.
Thank you.
Good job.
We've got Unity firmly attached and off to a great start on building the International Space Station.
The mission was a success. Two countries, once bitter rivals in space and adversaries in a Cold War, could now begin a new era of cooperation. The space station was ready to receive its first occupants, astronaut Bob Cabana and cosmonaut Sergei Krikalev.
When we got to the point where we opened the main hatch, Sergei and I went in together. That is a moment I will never forget. It's an international space station, and I really felt it important that we as an international crew enter together and joined.
We are so pleased and excited and proud to be a part of the team that made this happen.
By the time the International Space Station is complete, 16 countries will have made unique contributions to its construction. Starting with the foundation of Zarya and Unity, the station's third building block is the Russian service module. Installed in the summer of 2000, the service module provides crew quarters and propulsion. The European Space Agency will study the effects of weightlessness in their Columbus orbital facility. Japan's Kibo module features an exposed back porch for external experiments. The US lab concentrates on space benefits for Earth. And Italy's special detachable modules will transport cargo to and from the space station aboard the shuttle. These and over 100 other components comprise the 1 million pounds of space station hardware. The Russian space station Mir. It has been in orbit since 1986, 10 years longer than originally planned. By the year 2005, the International Space Station will grow to be 5 times larger than Mir and accommodate a crew of 7 astronauts. With its enormous solar arrays unfurled, it will be as large as 2 football fields. It will take 160 spacewalks to build this orbiting skyscraper. The NASA astronaut with the most experience doing this is 52-year-old Jerry Ross. He's logged over 44 hours of assembly work in space.
I need a handrail, number 120, I think.
It's very hard to describe what it's like to go outside in your own little spaceship, your spacesuit, and go out there and do things that you've been preparing to do for months, if not years in advance, is an incredible experience. For an engineer to think these kinds of things is kind of strange, but I really felt like I was at unity with the universe. I felt like I was out there doing exactly what God had designed me to do. What a tremendous feeling that is.
The space program is truly a family matter for Jerry Ross. His wife and daughter also work on the space station team.
My dad's been a space enthusiast since the start of the space program. He made scrapbooks and model rockets. So he always knew he wanted to work in the space program in some way, shape, or form.
She saw the kinds of interesting and fascinating things I got to do, and I think through that, she started to think about what she wanted to do when she grew up.
All of us wish we could take our families along. Here's Jerry all cleaned up after a hard day at work.
Dad's last mission was STS-88, the first space station build mission, and he wore gloves that I worked on.
I gotta tell my daughter these gloves are really great.
I think he's the best astronaut at NASA, but of course I'm prejudiced.
Jerry, look back at us, please.
Nope, that's it for Wes.
On their spacewalks, astronauts install handrails to help them move around the outside of the modules. They wire electrical equipment, deploy communication antennas, position tools, assemble and operate cranes to move large hardware, and they attach mountings for future modules and other equipment. In all, it will take 1,900 man-hours to assemble the space station, which means if they work non-stop, it would take 3 months solid, 24 hours a day, 7 days a week.
In a way, it's like trying to build a ship in the middle of the ocean in a storm, having many different countries providing pieces and hardware and personnel, and having all this done in an environment that is really hostile to life and to equipment in general.
Space is a hazardous place to work. Without an atmosphere, the radiant energy of the sun causes dramatic temperature changes to the astronauts and the equipment they use.
In the shadow of the space station, you might be working with tools that are minus 100 or 120 degrees, below 0 Fahrenheit. On the hot side, in the sun, you might come into contact with things that are 250 degrees above Fahrenheit. And above that, you'd start to melt the spacesuit glove, and that's something we like to avoid as well.
The temperature difference between these two astronauts working side by side could be as high as 350 degrees Fahrenheit. Their $12 million spacesuits protect them from these extremes. But working outside the rapidly orbiting station still poses certain dangers. Though it doesn't appear so, to maintain an orbit, the space station must travel at 17,500 miles an hour. To illustrate how fast this really is, we can bring the space station down to just 1,000 feet off the ground. From Dallas, Texas, at orbital velocity, it would take only 17 minutes to travel the 5,000 miles across the Atlantic to Paris. Everything on orbit moves at this speed, so just as a large asteroid hitting the Earth would cause devastation, any debris striking an astronaut could be deadly. Layers of Kevlar, Teflon, and aluminized mylar would shield an astronaut from a projectile the size of a grain of sand. But if the object were larger, Exposed to the hard vacuum of space, the astronaut could use reserve oxygen to try to survive.
If it's a big hole and the suit does not maintain pressure, then you're going to lose gas, but you're also going to lose heat, so your body tissue may start to freeze there as well. You may be unconscious by that point anyway.
No spacewalker has ever been injured on the job, but accidents have happened on orbit. And NASA figures the odds that an astronaut will be injured by orbital debris as 1 in 496 over the expected 15-year lifespan of the station. The best way to reduce these odds is to keep the astronaut inside as much as possible. From the annals of science fiction comes the answer to our problems. Teams of engineers at NASA's Dexterous Robotics Laboratory have developed a prototype robot to minimize man's exposure outside the space station.
There are a number of roles that humans are just not well suited for. We did not evolve to operate in space. Therefore, we'd like to have robots take some of the burden off of the astronauts.
Meet Robonaut, the first of a new generation of robotic astronauts created in the image of man. Robonaut faces the harsh environment of space, while its operator remains safe in the space station, using virtual gloves and headgear to operate it. Mimicking the most subtle astronaut movements, the robot hand performs delicate and complicated tasks with the dexterity of its human counterpart.
Robonaut can just work the way you work, picking up a tool by hand and doing the operation in a natural way.
Located permanently outside the station, Robonaut can prepare work sites in advance and be ready to respond in case of any emergency.
The robot can always be ready, just moments away from having to take action, maybe to save the spacecraft. We call that the Minuteman role.
If a meteoroid should impact the station, it could take several hours for an astronaut to get into a spacesuit and pressurize for a spacewalk.
Over the course of those hours to get a person outside, well, it might be too late. Robonaut would allow that astronaut to get outside in kind of a virtual way and take charge quickly of the scene.
Wearing a remote camera headset, the operator sees through the eyes of the machine. Robonaut has stereo vision, giving the user depth perception and the ability to work in 3 dimensions.
Spacing the eyes, similar to the human eye spacing, that interocular distance gives the same kind of depth perception that you might feel just looking at your own hand, maybe 2 or 3 feet away from your eyes, and allows a very intuitive approach to controlling the robot.
Robonaut's sophisticated hand design contains 46 sensors to help it feel objects, just like a human hand.
The reason for developing a hand was essentially everything on station is designed to be interfaced by a suited astronaut.
Rather than building a new set of tools, NASA designed Robonaut to work with existing space station tools. Weighing in at only 6 pounds, this amazing hand holds great promise for amputees here on Earth. But for now, Robonaut is reserved for astronauts on the space station. While Robonaut's machinery is unaffected by weightlessness, the human body is not.
Living in zero gravity, you become fully adapted where flying is normal. Letting go of something and have it float there is normal. Having to strap down with a bungee cord every item, your toothbrush, your comb, your toothpaste, the cap to the toothpaste, all the pieces of a scientific experiment, that becomes normal.
50 feet at 245.
What seems abnormal is when you come back to gravity. That is hard.
We're dead. Oh, man, what a landing. Good job.
I, in my case, lost 12 or 13% of the bone mineral in my pelvis due to the lack of loading.
Without gravity to put a load on our muscles and bones, they can simply dissolve away. If humans are to survive in space, how are we to overcome the limitations of our own bodies?
Gravity comes on slowly as you re-enter in the space shuttle. Your blood gets pulled down into your legs, and your wristwatch starts feeling like a brick if you've been used to zero gravity.
This is what astronaut Dave Wolf recalls upon returning to Earth after 4 months on the Mir space station.
Good luck. Well, thanks for all the help. I can't say enough.
A 44-year-old medical doctor, Dave Wolf has logged almost 150 days on orbit. He's an expert on the physical effects of spaceflight.
It's very hard to walk. It's a huge effort, and you're very happy just to sit down in a chair and not move.
Adapting to and from weightlessness is a challenge for the human body. Without the effort required to work against Earth's gravity, muscle groups weaken and atrophy. Without resistance to movement, the bones themselves lose strength. Calcium simply dissolves away, and bone mass drops 1 to 1.5% for every month spent in orbit. To slow this dangerous effect on the body, astronauts exercise 2 hours a day. But eventually, an answer must be found to this and other health problems if we are to continue exploring our solar system. On a deep space voyage, what would happen if an astronaut needed immediate surgery hundreds of thousands of miles from Earth? Scientists at NASA's Ames Research Center are developing technologies to address medical procedures in space.
Okay, so the three-dimensional reconstruction of the rat is coming up, and I can place my scalpel and make the incision.
The first step is to create a virtual reality environment for the weightless dissection of laboratory animals. This simulation allows astronauts to train for these delicate experiments here on Earth.
What we're trying to accomplish with this technology is to tackle the problem of not being able to train in microgravity for any extended periods of time before a mission. What we want to be able to simulate is this types of subtle motor differences that you need in surgical procedures when you're in microgravity environment and you can't count on everything settling downwards.
Dissecting with weightlessness has never really been done before, and this is a new frontier.
Another breakthrough device that may help astronauts in case of a medical emergency is Smart Probe. Developed by research scientist Robert Ma, it can diagnose tumors in the body with a simple touch.
And the idea here is that you stick the probe through tissue, it's telling you in real time what's being sensed, whether it's a muscle, whether it's an artery that's approaching, or whether it's bleeding or a type of cancer.
Smart Probe identifies the tumor using 5 sensors, measuring tissue density, light and color variables, temperature, blood flow, and sound waves. Technology for the space station developed at Ames will lead to tools which mentor astronauts through medical procedures. On Earth, it could allow the creation of a virtual surgery network where doctors across the globe can interactively share their knowledge. International cooperation like this benefits all of us. The Russians contributed by sharing with NASA their space station experience.
We learned so much by working together with the Russians on the Mir space program. To say which lesson is more important is like saying which number in a phone book is the most important. Well, the most important one is the one you need to call next.
The Russians have a long history in space station technology. Living and working aboard Mir provided valuable information for designing the International Space Station.
We're in the Crystal module now. I feel like I'm exploring a cave.
The Mir was cramped and stuffy, with temperatures ranging up to 85 degrees Fahrenheit. But certain features, such as porthole windows for a view of the stars in each member's crew quarters, made life tolerable.
Now you can see Node up there, an inviting place, kind of warm colors.
By contrast, life aboard the International Space Station is roomy and bright.
It's just an absolutely super place. Look at the volume Sergei is floating around in.
The temperature is maintained at a comfortable 70 degrees Fahrenheit.
That is scary. What is scary?
Much of our day-to-day living in space is surprisingly the same as on Earth, with the exception of being anchored while sleeping to keep from floating away. Without gravity, water forms into suspended bubbles, making personal hygiene a challenge. Using the bathroom requires restraints to hold the astronaut in place, a suction system to collect the waste, and a tube and funnel for urination. On the space station, even brushing your teeth is an adventure.
The little things sometimes become really big events, like just changing clothes in space without gravity. You know, putting on your socks is a big event. You know, just getting them out of a locker might be a big deal because you got to hold on to a wall or to a bulkhead to open the locker door. You just can't pull on it.
Food is better than ever. For the first time, astronauts have a refrigerator and microwave ovens. Along with the usual dehydrated fare, astronauts can enjoy fruits and vegetables, cereal and cold milk.
We broke out the drinks and some food. Jim's having some strawberries. Sergey's already into his dessert, got a big brownie there. And everybody is well hydrating.
Adequate rest and meals are important for astronauts because most of their time in the station is spent hard at work. Their exhaustive schedule includes maintenance tasks and installation of new hardware, the packing and storage of supplies and equipment, and a whole range of scientific experiments both inside and outside the space station. Perhaps the most important research is happening in medical science. Without gravity, chemical reactions behave differently. On orbit, molecules can be blended in substances created that are impossible to duplicate on Earth. In the laboratories of the space station, perfect crystals of human proteins can be grown in large number, which will greatly accelerate research on Earth for the treatment of diabetes, AIDS, and organ transplants.
The results we're getting in tissue culture using controlled gravity systems is already putting key pieces of the puzzle of tissue engineering together, a day when we will be building organs to order from a person's own tissue.
Despite the heavy workload, astronauts still find time to play.
Sit inside? No, outside. Oh, looks like inside.
Rice crackers and chrysanthemum flowers are held onto the ball of water by surface tension.
I don't know if we want to be on HDTV with that thing.
HDTV! And now, for the first time, the secret energy source of the space program is revealed. Cold fusion power? Dilithium crystals? No, it's ice cream.
Oh, fine. All right, come on.
Free time is spent sending email to their families, enjoying music and reading favorite novels.
I think it will be fascinating to participate in this project. Fortunately, we have one of the most incredible view out of the window that you can never get bored.
Going around the Earth 16 times a day gives you a spectacular panorama, which is continuously changing. From night to day, you see a sunrise and sunset every 45 minutes. So there's always something to see out the window that's very captivating.
From science fiction to science fact, a dazzling array of technology will assist our astronauts inside the space station.
The astronauts actually gave us the idea for this robot, or what we call the Personal Satellite Assistant, the PSA. Based on their experiences on the Mir, they really wanted sort of a tricorder, the device from Star Trek. So we added to the concept voice recognition so they can ask questions. And then we actually saw with ducted fans, not only could we have a PSA that would be just floating, facing them this way, they could also now go tell the PSA, I need you to go to the node 2 and check the temperature there. And it could go off on its own and actually do that temperature scan and then come back.
Organization and time management are critical in space.
Okay, I'm getting ready to do the next experiment.
With such a demanding workload, astronauts need all the help they can get.
So we'll start with the top one and work our way down. Since the PSA has a wireless network connection to the space station, it'll know the status of that crew member's particular experiment to help make sure that when they finish with one experiment, that the next experiment's going to be ready to go. The crew really likes those concepts. Take away some of the chores that they don't want to do, let the robot do it, and let them focus on really the leading-edge science, the experiments, and the critical mission operations.
To engineer a free-floating robot in the lab requires a creative new approach.
What we've done is something that maybe a lot of kids are familiar with. We've taken a 10-ton marble slab, and just like an air hockey table, we can actually have the PSA float across on this airbed, and that really comes close to mimicking the microgravity environment in space.
The technicians at Ames Research expect to deploy a fleet of personal satellite assistants to the space station in 2005.
We actually want one PSA for each crew member. So you wake up in the morning, you'll tell them what kind of information you want to know about, how much time do you have before you have to get ready for the next experiment, and sort of be a butler or assistant or a buddy working with you on board the space station getting your job done.
We are well underway towards building the technology that supports the astronauts. But how can we prepare them to cope with the emotional stress of long-term life in space?
Any future astronaut that occupies the space station for long periods of time will do so knowing that there are risks. Knowing that there are the risks of getting hit by a micrometeoroid, knowing that there are risks of radiation from the sun. We shouldn't think lightly of the challenges of living and working in space.
Not all dangers in space are external. Sometimes they come from within the human mind.
3 metro, first right here.
You must always look at spaceflight as a very critical business, very unforgiving environment. And if we can't face that environment, then we don't belong as a spacefaring nation.
June 25th, 1997. Despite protests that they were physically exhausted, the crew of the space station Mir was ordered to proceed with the manual docking of a supply capsule.
3 metro, first right here.
The impact caused a breach in the hull. 15% of the station's air was lost before the damaged module could be sealed. There were several reasons for this near disaster, but prolonged stress on the crew was an important factor. To cope with the emotional pressure, the isolation, and the constant awareness of danger around them, space station astronauts go through a minimum of 2 years of intensive training. The psychological and physical tests they must pass provide them with the knowledge to handle any situation automatically. There's much work to be done to earn the right to wear this flight suit. As an international partner in the space station, Canada is hosting a boot camp for the psychological training of astronauts.
And you're going to learn tomorrow that your clothing, to stay warm, it's got to be worn loose and in layers. So if it looks a little baggy, that's real good stuff.
The Cold Lake training program tests a group's ability to work as a team under the harshest conditions. Subjects are given a crash course on winter survival. The instructions are given once, and once only.
So if it fits okay, we're off to the races.
Sleep deprivation plays a crucial role in this training. Just hours after they've arrived, they're suiting up for their first day in the field. Learning to use snowshoes is a new experience for most of these astronauts from Houston, Texas.
You want to get this done as quickly as possible, because you want this tent up in 5 minutes flat and free.
Might seem kind of odd how, being on land in the cold is analogous to being in space, but they each offer separate challenges that are kind of similar.
Well, if you could imagine being on a space station with a crew, you would have 6 or 7 people perhaps in a confined space. It's not cold, but they're under conditions of weightlessness, so meal preparation suddenly becomes very complicated because everything floats. Well, you have the same kinds of problems in a cold environment. Taking care of the stove and making meals is very complicated, but everything freezes and you have to accommodate that.
His tent will be their only home and shelter for the next week. It measures barely 10 feet across.
You've done a bang-on job. It took you 19 minutes. You want to get her up in less than 10, and in the real cold, less than 5.
The group flies 30 miles into the wilderness to spend the remainder of their time alone, without their instructor. They are required to perform scientific experiments on a tight schedule, and are randomly ordered to pack their tent and move camp, hiking for miles in sub-zero weather.
What we realized in the first 7 missions of the Shuttle Mir project is that people could be better prepared for this kind of isolated and confined environment. And certainly the cold weather environment is one that challenges a person physically and mentally to adapt.
The team has only the equipment they've been given and themselves to rely upon. Leadership within the group is assigned on a rotating basis by mission control. The rivalry between veteran and rookie can sometimes cause friction when it comes to giving orders.
Okay, remember, you got to loosen up this slack for...
We were fortunate in the 6 members of our mission that we had, that we all got along really well, but, you know, in some situations that doesn't work out.
Short wall here, but it's good enough. We're good.
A lot of a person's ability to be a good leader depends upon people that they're working with to be good followers and to be able to support the leader and to work together.
Shannon Lucid is an icon at NASA. Incredible as it sounds, in her 57 years, she's logged almost 5,500 hours in space, receiving both the U.S. Congressional Space Medal of Honor and the Russian Order of Friendship Medal for her time on Mir. Shannon Lucid knows the importance of teamwork under pressure. Forced marches at midnight when the temperature can drop to negative 23 degrees Fahrenheit, carrying 75-pound packs and dragging a 200-pound toboggan, it's vital that the group hold together and cooperate to complete the mission.
Whenever you're stressed and pushed to your own personal limits, you have an opportunity to look inside of yourself, to question your motivations, to look for where you draw strength and what motivates you, and how sometimes you can't just succeed as an individual, you have to succeed as a team.
But the psychological conditioning of cold leg is only one part of their rigorous training program. The most dangerous 8 minutes of every trip to the station begin with the shuttle launch. Accelerating at 2,800 miles an hour on top of 500,000 gallons of liquid rocket fuel, anything could go wrong.
Roger, roll, Endeavour.
This motion-based simulator prepares the astronauts for the problems they might encounter by duplicating any portion of a space station mission.
Single engine, Zaragoza, 10.
VFS drop track.
Trainers in a control room conduct this simulation, sending curveballs at the astronaut, such as a temperature drop or a voltage problem with his equipment, and gauge his reactions on how well he deals with the situation.
Okay, roger, I copy. Break D, Charlie to Alphabet Tech.
At the same time, some 30 people in mission control are part of the exercise as well, working with the astronaut to solve the problem in the most efficient way possible.
Charlie Alpha, press fuel cell 3.
In all, there are over 100 personnel involved in this training. And there are more elaborate exercises required to be part of the space station team.
Good readback.
Assembling these giant modules in orbit call for skills most astronauts have yet to acquire. How do we practice for such an undertaking? For those who build the station, the rehearsal for outer space begins in inner space. This is the NBL, NASA's Neutral Buoyancy Lab. Containing 6.4 million gallons of water, this enormous pool covers 20,000 square feet and is 4 stories deep. Working underwater, the weightless experience on orbit is closely duplicated. Training on these full-size mock-ups, astronauts are able to perform their complex assembly duties many times over before ever attempting them in space. To achieve neutral buoyancy for the effect of weightlessness, astronaut suits are balanced with lead weights and blocks of styrofoam, until they neither sink nor float. Overlooking the tank, supervisors in a control room monitor the activities below on video. Cameras record every angle as the astronauts run through a carefully prepared script that details all aspects of the underwater spacewalk.
So this is on the zenith side.
That's correct.
Okay.
It really is the only place on Earth that we can really choreograph the details that we're going to need to do up on orbit. We're going through the very precise tether swaps and how we're going to hand off tools and make connectors. It's a very difficult choreography.
Continue the roll another 45 degrees or so.
Still moving, report left.
For every single hour an astronaut spends walking in space, he'll typically train for 10 hours underwater.
Very seldom is it a huge thing that makes the mission not work. It's some little detail that we overlook. So the excruciating detail we go to try and make sure that everything is as realistic in our minds as possible and in the mock-ups as possible, so that when we get to space, it'll feel familiar and easy as if we've been doing it our whole lives.
The intensive training that astronauts receive prepares them to handle any task on orbit or any crisis getting there. An aborted liftoff of the shuttle could require a water rescue. In that case, these flight suits become the Swiss Army knife of survival gear. Built in is a parachute, self-inflating life preserver, flares, dye markers, a flashlight, drinking water, a signal mirror, radio, and even a one-man raft. Off the coast of Japan and on Russia's Black Sea, the international partners are training their space station teams in exactly the same techniques for survival.
Why don't you try to bring me forward, pal? See if you can bring me forward an inch.
This day is a special occasion at the Neutral Buoyancy Lab. This is the first trial run for a critical addition to the station, a newly designed 55-foot robotic arm.
We in Canada, we dub it the Canadarm, but at NASA it's called a remote manipulator system.
Canadian astronaut Julie Payette is 37 years old.
And Discovery Houston for station?
She's logged over 235 hours in space.
Julie, we copy, thank you.
She's a classical pianist and singer and a special technical advisor for the Canadian robotic arm. The system is designed to latch onto one end of the space station, then detach the opposite end and reposition, giving it access to every module by inchworming its way across the massive structure.
It's actually quite essential to the building of the space station and later on to the servicing and maintenance of the space station.
Prepared for almost any emergency, what would happen in the worst-case scenario? A breach in the hull, or a fire on board the space station?
Get there, strap him in over there.
The crew would need a way to abandon ship. Like any ship at sea, a space station needs a lifeboat. As it has for the Mir, a Russian Soyuz re-entry vehicle will serve this function on the International Space Station. The Soyuz has proven reliable as a workhorse for the Russian space program. But its technology is 25 years old, and its small size can only accommodate 3, not the entire 7-member crew that will inhabit the new station.
From here you can see the orbital module above us.
To replace the Soyuz, NASA is developing a rescue craft called the CRV, or Crew Return Vehicle. The first step in making this lifeboat a reality is an unmanned test model called the X-38.
Okay, we are verified. EMA, high power, coming up.
Gotcha.
Ready for flight sent. You can go ahead and launch.
3, 2, 1.
Engineers test the electrically powered flaps that maneuver the craft when it flies through the air.
All brakes are on, stop.
The checkout of the control system is complete, and now the X-38 is ready for the next test, dropping it like a bomb from under the wing of a B-52, 7.5 miles above the Earth, and guiding it to a safe landing by remote control. The CRV will not go into service until 2006, but crews are already training on Earth for the escape procedure. Like a roller coaster, this jet climbs and dives repeatedly, causing everything inside to go weightless for short periods of time. Not surprisingly, it's called the Vomit Comet.
Go. Quickly. Yeah, really? Yeah. Just lay still. I got lunch. 10 seconds. You get there, strap him in over there.
What they do would be they go through a connecting tunnel into the vehicle, close the hatch from the inside. There's a single button to activate all the systems, and then cold gas jets fire to push the vehicle away. We fly away using the cold gas jets for about 20 minutes, and then we orient and use rocket motors on the back of the vehicle to slow it down, so then it starts to come down out of orbit. Then we position it so the nose is pointed forward, and we pitch up to 40 degrees to the velocity vector, and we fly in just like the shuttle, down to 23,000 feet above the target. Then pull out the main parafoil. Then once we're flying under the parafoil, it's just like a skydiver's ride, and we fly to a very soft touchdown.
With the X-38 attached under its wing, the B-52 is ready for takeoff. This bomber is older than most of the team members working on the X-38 project. For over 40 years, it has test flown nearly every experimental craft the U.S. has designed.
I don't think a lot about the day we first put it on the station. That'll be a great day. There'll be plenty of celebration, and it'll feel really great that we have one. The day that really matters is the day that someone gets in this vehicle to come home, and their life and their family's life and the whole program is going to be dependent on that working right that day. The CRV is the first vehicle ever uniquely designed for space rescue. And I think the other thing that keeps the team going is to have worked so hard on this and then to have the reward of flying it.
Okay, in all stations, 25 minutes to launch. 25 minutes to launch.
People aspect of this program is probably one of the more interesting aspects. It's truly a team.
Et ça, c'est pas grave. Ça, c'est une structure, c'est facile à refaire.
In the X-38 program, we do have a large European contingent that's working with us. The European Space Agency is a partner with us in the X-38 program.
In the Netherlands, they're building the rudders for the space test vehicle. In Spain, they're building the landing gear.
The Germans had come up with a very interesting, very unique composite material, the thermal protection system that we're putting on the nose of that vehicle.
In France, they've done a lot of the aerodynamics work and aerothermodynamics work of the new shape. Even small countries, Belgium, for the space test vehicle, built a lot of the structural parts of the aft of the vehicle. So it's really been all across Europe.
LPO, we copy. LPO, we copy and confirm, and we are go for launch.
Just before launch, the B-52 sends out a stream of white smoke to signal the crew on the ground.
And we 5, 4, 3, 2, 1, launch, launch, launch. Away.
The X-38 is in freefall, dropping at a rate of 500 feet per second, 39,000 feet off the ground. The small drag chute slows the X-38 down and reorients it horizontally so the parafoil can be deployed from the top. The parafoil deploys in stages, triggered in a precise sequence by pyrotechnic cutters buried within the lines. When it's fully opened, it is the same surface area as the wingspan of a Boeing 747.
Okay, Chuck, you seen any more of 800 there?
It's about thinking differently. It's why there's an X in front of the X-38. It's an experimental vehicle. It's about going off and really trying to create the new technologies, and we encourage the people here to think that way.
Unlike the space shuttle, the skid-type landing gear on the CRV does not require a runway to land. And unlike the Soyuz, the parafoil can be steered so the astronauts can choose their landing site.
It's fun to come to work here because of what you're doing and because of where you know it's going. When you get an idea on paper and you turn around and then it's right behind you, that's pretty exciting. And there's not a whole lot of places on the planet you get to go do things like it.
My whole life growing up, all I saw were images of the Vietnam War on television. And I think to myself, here we have an opportunity to not have war be the defining factor of what is the politics of nations, that a major collaborative effort is. And that'll be a very different dream for the next generation to think about.
More than 45 launches are needed to build the International Space Station. The crews for these missions all share a common spirit for adventure and a passion for the work that they do.
And we do have live TV from the suit-up room. Our mission commander, Bob Cabana, is making his 4th trip into space.
51-year-old astronaut Bob Cabana has logged over 1,000 hours in space, including the first mission to build the International Space Station.
How's everybody doing?
I just wanted to fly airplanes when I was young. I always had this desire to fly it. You know, I could never get rid of it. When I'm looking at this spaceship there on the pad, it's fueled and it's venting and it's creaking and it's like it's alive. And you say, I can't believe in 3.5 hours I'm going to be inside there taking off into space.
MPD, you're clear to launch and have a great mission. Thank you very much.
I mean, those main engines crank up and the whole orbit kind of moves forward from it and then back, and then when it hits the vertical, the solid's light. It's shaking and vibrating, and you're trying to read the gauges, and you're being pushed back in your seat. And you just remember this sense of speed. It's just a sense of acceleration.
Throttle up. Roger, Houston, go at throttle.
There's a bang and a flash, and you see the solids fall away. And then you're just on those 3 main engines, better than 1/3 of a million pounds of thrust in each one. It's hard to breathe. You've got a 3G acceleration, and you hear this bang as you're separating from the tank, and you hear these 800-pound thrusters going off. It's like a cannon. Boom, boom, and it's shaking and vibrating, and you're in space, and it's quite a ride.
In the Space Shuttle's 20-year history, only now does it satisfy its original charter, to be a transport vehicle between Earth and an orbiting research facility. The International Space Station is the culmination of this program. Orbiting the globe 16 times a day, it serves as a platform for our return to the Moon and for the future manned exploration of Mars. When complete, it will be visible from nearly any point on Earth. And our children will never know a time when we did not live in space.
We're living in a time where the domain of the dreams are no longer relegated to the pages of science fiction books. We're living in a time where we can actually make that a reality.
We look behind the unopened door when we build a space station. We peer into this vast unknown, into this vast creation, and we understand both our significance and our insignificance, and that's what we want to do.
If we're not pushing the limits and going boldly where no one has gone before, we stagnate as a culture.
Life in zero gravity is a whole step of evolution. Can we have a baby in zero gravity? Will it develop properly? Or will it be a new organism at that point that perhaps can't return?
I see the space station as something that gives us hope that what we call our backyard is more than just our tiny little speck we call Earth. Our backyard is, in fact, the solar system. These are dreams that inspire children to become scientists, that inspire people to think beyond themselves.
We don't know what's out there, but history has taught us that what we find will be of much greater value than the things we thought we would find. And I can't imagine us as human beings turning our back on exploring.